My name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, a show about application development and management at scale. Thanks for joining us.
This episode of the New Stack Analyst is brought to you by Oracle. Oracle Cloud Native Labs is here to empower the next generation of cloud practitioners with a curated set of solutions, tutorials, and best practices, all designed to spark inspiration, drive hands-on experiences, and unleash our industry's potential. Good morning, good morning, good morning. Hey everyone, how are you? Welcome to the Pancake Breakfast and KubeCon CloudNativeCon. So excited to be here. I'm Alex Williams, founder and editor-in-chief of the New Stack, and we have a panel here today to discuss mono to micro, FaaS. I'm going to look at this, a macro challenge. First, I want to thank Oracle for sponsoring this Pancake Breakfast. Please give a big hand out to Oracle for making this possible. This is a lot of fun. So what I'm going to quickly do is just introduce the guests. But before that, I just want to give you kind of the basic format for what we do here. The whole idea is to have a discussion. And so you have your tickets. Everyone have their tickets? Everyone? Oh, we have one person in the back. So anyone who asks a question, they get 5 extra tickets. So then we'll have a drawing for the prize, Arduino starter kit. The discussion today, I'm really excited about this, is, how do we think about this transition to these cloud native environments, and how do you think about Kubernetes, and what is that connection to serverless? And we write about this all the time. We discuss it on our podcast, but this is the opportunity for us to kind of get a perspective from people who are actually kind of out there, who are kind of implementing this stuff, trying to get these new cloud native approaches into production. So what I thought I would do is just, first of all, introduce the panel. So why don't we just go down, why don't we start with you?
Sure. My name is Sara Pulido. I work as an engineering manager for a company called Bitnami. We do basically most of our expertise on application packaging, and I run the Kubernetes engineering team there.
Check. My name is Chad Ariamira. I am the VP of Serverless Advocacy for Oracle. I was part of the, helped form the serverless engineering team, and then I moved over to an advocacy strategy group. And if you're not familiar, Oracle has a very large cloud infrastructure offering, as well as a lot of announcements this week around serverless and cloud data framework stuff. So think of it as all kind of CNCF, fully enterprise version, supported version in the cloud and on-premise as well.
Hey, my name's Christopher Woods. I work as a research software engineer at the University of Bristol. And what I do is I basically help our researchers use cloud technologies to really advance the sort of sphere of human knowledge. So we're always on the edge of what's possible with a computer, because we have these ridiculously big calculations. And so recently we've been moving into the cloud because, one, we get a lot of it for free, which is always a benefit. But equally, it's just offering us sort of a potential to do ridiculously huge planetary scale simulations. So
I'm Tom Petroselli. I'm with Amalgam Insights. My title says Research Fellow, which means I'm a really senior analyst. We are industry analysts. We look at the market, the technology, how it's used, who's using it, all that fun stuff. And I have my serverless paper is out this week, and it's free this week because of KubeCon.
Where do you find it?
You can find it at our site, amalgaminsights.com, and hit the research tab, and it's right at the top.
Excellent.
And,
excellent.
That's our gift to you all.
Well, great. Well, I would love to just start it off by asking Christopher a question. I'd like to hear more about your journey, really. You do a lot of research, and you were talking about this approach, but tell us about how you have been, running your own infrastructure for the researchers, and how it was set up, and how you started to make that transition. What were the business cases for it?
So as I said, with research, we're always trying to use the absolute latest technology and sort of pushing the boundaries. So I started really on my journey to the cloud way back at the end of the 90s when we were building the first Beowulf clusters. So who here remembers Beowulf clusters? Who here cut their teeth basically wiring together white boxes and putting them on shelves? Because that was the beginning of my career. And ultimately you were doing this because you needed to sort of push computing to places it had not been to before. And that kind of evolved in universities towards, we worked out how to use Beowulf, which then turned into our Linux clusters, which then became our on-premise machines. But then those machines are kind of ossified really over the last 10 years. They've been exactly the same. They haven't really changed, but the research needs, the drivers have just been kept evolving and kept scaling beyond what an on-premise machine could give us. And then suddenly along comes the cloud. And what the cloud is giving us, it's almost like it's Beowulf again. We can sort of wire together all of these different technologies and play with them and experiment and see, can this solve our research problem? And what we're finding is, yes, it can. We're now sort of running these huge simulations that are spanning the planet, that are throwing data all the way around the world, and that are just enabling us to do things that we couldn't possibly do if we were trying to run them on premise. But the main thing that's really driving it is this kind of idea of the stack. That ultimately what we're doing is, as you're producing more open source software, more technologies, the bottom of the stack is just continually raising up. Back in the early 2000s, I was building data centers and putting together clusters, but now the stack has moved up and I shouldn't be doing that. Now we're working at the point where we're building these huge sort of serverless, I don't really like the word, but serverless frameworks, and the stack keeps rising. And as the stack rises, we, the university side, always want to work at the top, because that's where we add value. And ultimately, everything off the bottom, anything that can be commoditized and we don't have to care about, we just push away. So ultimately, that's what I think is the driver that's pushing us in this direction, is that the stack keeps rising and other people, for example, like a function service, we can just throw that all over to them and we don't have to worry about it.
The stack keeps rising, huh?
The stack is always rising.
And you do planetary research?
So actually, one of the projects next year, which we'll be using with serverless functions and object store, is we have satellites, Earth stations collecting atmospheric data, and all of that is being thrown into object store with serverless functions processing it, cleaning it, throwing off simulation, which will then backtrack. So for example, if you pick up some methane that's floating somewhere above England, we can then do some CFD calculations.
So is this like a spaceless approach kind of thing that you're working on here?
Possibly. But this means our methane can then be tracked back to the individual cows from which it came.
That's fascinating.
And it means we can then give actually our climate change report. So for the UK, it would mean we move from the kind of the old system where this data was collected and emailed to each other,
right,
to this kind of now automated, autonomous, cloud-based serverless system where the researchers don't think about the infrastructure, and I think that's the key thing.
So I have a question for anyone in the crowd. Who is seeing this proof of this rising stack? How would you see that inside your own operations? Do you see this? You got one. Tom, I'm curious, Tom, from your perspective, is this an outlier or is this really what we're seeing?
No, it's not only what we're seeing, it's what we've always seen. And that's kind of what's so funny about this, because these kind of distributed applications that abstract much of the infrastructure have been around in one form or another for a very long time. What's different now is that it's getting much easier and much more economical to do it. When I wrote my first distributed application in the 1980s, it was really expensive, very expensive workstations. We used to use things called transputers. Anybody here remember transputers? Wow, that blows my mind.
The transputer came from Bristol, which is where I'm from.
Oh, cool.
That's why I know about it.
So we used, and a lot of it was this sort of peer-to-peer communication model, a lot of shared memory models, all of which were really wonky and hard to use. And but if you fast forward now 30 years, what you find is that a lot of the problems of doing distributed computing have been worked out to where they're very much abstract from the developer, and I think that's what's new. So this idea of the rising stack, or I tend to think of it as abstraction from all the worries, if you will. Whether you're on premises or in a managed service cloud, I think that's really been the movement that we've been heading for. And as we look forward into the next couple of years, our opinion has been, at Amalgam, has been that we're going to see more of that. We're going to see this is a high level of abstraction, but you can actually go even a little higher. The stack can go higher.
So Chad, I'm curious from your perspective then. You've been working in this space as long as anyone I know. You founded Iron.io. It was an open source project. And you joined Oracle. I'm curious about what you see now that is reflective of your own early days and how you see it from here moving forward. I mean, you're starting to see, and then I would like to go to Aaron and ask about this kind of interconnection between that and Kubernetes. So maybe you could just give us some perspective from your point of view.
Yeah, I think, so we founded Iron in about 2011, and we created something called Simple Worker, which became Iron Worker. And it's funny because in 2010, we were running a consulting company, and we wrote this system that, for a consulting company, the idea is to write as much code for your clients as possible, as quickly as possible, and not have to worry about anything else that's, losing you money. Because you make money with the time that you're actually delivering to your customer. And your customers don't care what's under the hood. They just want their application to run, and they want it to work, and they see, and they feel, and they touch, and they draw. So they don't care about a lot of the extra cruft underneath. So we were like, why are we writing so much cruft for every single application? Let's just refactor this out, make it one shared system that all of our clients can use, and then that will help us deliver faster for them. And that became this system where you could zip up some code, send it to a platform, and then you could call an API, and it would run that code for you. Now, fast forward, it sounds pretty familiar. In 2014, that's when Amazon Lambda came out, and that kind of kicked off this revolution of massive managed service based off that. And so for us, it was all about doing less. I've been saying this. I said it yesterday in a talk that I gave. It's like, it's like the surfing analogy in Forgetting Sarah Marshall, where Paul Rudd is saying, do less, do less. And it's about thinking about doing less complexity. For us, that meant making more money. And I think for our enterprise customers at Oracle, it's about delivering faster and worrying less about the stuff that you don't want to worry about, and making your job and your life easier, making you a rock star. And so I think that's what it's really all about. And the industry seems to be really hung up on definitions, like, is it functions? Is it storage? Is it on-prem? Is it in the cloud? Is it a cost model? Is it this? Is it that? And it's like, sure, it can be all of those things, but I think it's just about making your life easier as a developer and worrying less about the heavy lifting and the undifferentiated as an organization. And so I think as we continue to evolve, it will just be easier and easier. We're not quite there yet, unless you lock into all of the tools that a single provider gives you, because you get their experience. But I think we're getting there. And I think this conference is helping push that forward with a lot of practitioners as well.
Era?
I think one of the distinction of function as a service versus serverless and trying to come up with a name for it, I think the important thing for function as a service is basically a new tool on tool belt for a developer. They have a way to just create code and get it running. If as an organization you run that, as Chad said, on the public cloud as a single provider, it becomes more serverless from an infrastructure point of view, because you don't have to care. But still, for example, if you're running Kubernetes in your organization and you're managing, you have an infrastructure team that runs your cluster, and you still want to provide that tool to your developers, you still can, because there are a lot of platforms that can run on top of Kubernetes that provide that function as a service functionality. Still, in that case, from an infrastructure point of view, it won't be serverless, because you're still running your Kubernetes cluster, you're still running your servers, but it gives the benefits to your developers, which is the ultimate goal. So this is all about making software development more agile, easier for developers, faster.
Great. So we have our team here from the New Stack, and my co-host today is Joab Jackson, managing editor of the New Stack, and he has the mic. Are there any questions? Great. We have one over here and one over there.
What are some of the more interesting things that you've implemented as functions as a service?
So you said, what's some of the more interesting things that we've implemented as functions as a service? Do you do all of us?
Anyone?
Go ahead.
Yeah, go ahead.
So So one of the things
Probably it's you. So.
Okay, so we've implemented, boring stuff, we've implemented a complete identity management, accounting and access infrastructure as functions as a service. So this means that because we have all these things, devices, people, things that have to log on and basically submit data, we don't want to be running identity servers and doing key management and all of that stuff. So the whole thing has been implemented as serverless. So ultimately, all the data is object store, all of the logins are calling single functions, the whole thing scales because, functions as a service scales, and we're not running things in the background. The more fun things that we've implemented as serverless is basically big simulations. So the way you would typically run a simulation on a supercomputer today is you would basically submit it to a queue and it would run in a queue and it would do its work. We've packaged the entire application up as a function. So if you want to simulate airflow over an engine or airflow over an airplane wing, that is a single function, and you basically put the input in as the argument of the function. It runs it in the background. It could be running for a long time. The results go onto object store, and then it sort of sends you back a ping saying this is the bucket in which the results now sit.
It's one that you mentioned, that your functions may be running for a long time, and I think that's a good point, because some of the things that we think about function as a service, that the function has to run really quickly and then turn it down. So what do you think is a good use case for function as a service? It's because it's running, the running time is short, it's because it's event driven, it's because can be run in the background. So what are the things that you think make a good use case?
So for me, a function is a unit of logical work. So it's do something. It's the complete thing of doing something. So for example, log me into this service, upload this, process this satellite data that's just been uploaded, run this calculation and give me a result. So anything that you have a task which the event is something wants that task to take place, and the event triggers the task to take place, and that unit of work, that task is then run. So it's very similar. We do a lot of task-based programming down at sort of the low level, where you break up applications into tasks and then the task scheduler then distributes them across your cluster. I see serverless functions as being a task scheduler where the tasks are now distributed across the planet.
So I don't, it's interesting because that kind of an application, simulations, for example, or heavy-duty data crunching kind of applications are the classic distributed application. So in the past, what you had to do was deal with all the inter-process communication, and what you get with something like function as a service is you can kind of abstract, again, we're back to abstraction. You abstract all that so you can just have a unit of, you're saying a unit of work, I think of it as an atomic coding. So when your code can be very finely atomic, very finely grained, that's really a good use case for function as a service. Just as the first use case, where you have something that runs infrequently, and typically what you want to do is fire off a bunch of other things to happen. You can call them functions, whatever. But you want a bunch of other things to happen, and then it goes to sleep because it doesn't happen very often. So you're seeing both types of use case instead of having to have all this plumbing to run, say, a transform. Which is the kind of things you do in this kind of simulation work. So if I'm doing something like a transform, I want to just do the transform, go to sleep, because then I've done my thing.
Mm-hmm. Chad?
Yeah, I can give some examples of customers from my previous company and also at Oracle. However, before I say that, I typically get asked what's a good use case for serverless. If you're talking about serverless, I think a slightly contrarian answer would be anything. I mean, at the end of the day, it's just code. It's just services that you're calling. I think anything can be a serverless architecture.
But that doesn't help.
Yeah, I know. Sorry. Sorry. But, I mean, it's
you're thinking of the resource then. You can program the resource accordingly.
Well, if you think about serverless as not just functions as a service, now you're now getting amazing services from the cloud providers that do really great things, and you're not even calling a function. You're calling, for example, an artificial intelligence API or an email API or a text message API like Twilio. So can you create an app? I mean, right now you need a function to do that, but a lot of these platforms, you can actually run code right on them without even creating a function. It's pretty incredible. So you can remove a lot of the heavy lifting without even dealing scaling with the functions as a service. But today, FaaS is the base platform for compute and for serverless compute. And so there's some really great use cases. One is really boring. It's not exciting, but honestly, I think the lowest hanging fruit are automation and DevOps. We used to say like, oh, it's going to get rid of DevOps, which is kind of stupid because there's still lots of operations to this stuff. But ironically, the DevOps teams at a lot of our customers are finding amazing use cases because it's all very event-driven, and it's all very tied into the cloud platform that you're using. So whether it's, you can actually get Kubernetes events, but we won't talk about that. We'll talk about like getting your S3 changes, your Oracle Object Store changes, or every time a server launches, it will trigger a function. You can check it for whether it has the right tags or the right cost model tags appropriated to it, or the right security settings, or the right ports opened and closed. You can do all these things that cron used to do. And what happens when that cron server goes down that's been running for 6 years and nobody knows where it's at anymore? So you move these to a serverless model, to a function as a service, and it makes life a lot easier. The final thing I'll say is just a couple use cases that I saw from my previous company. Sending news alerts. So one of the largest news providers in the world would batch out a ton of news alerts, so they could send like 10 million news alerts to customers in under 5 minutes. And their goal was to send them as quickly as possible to beat their competition. So you get sort of this massively parallel distributed pattern. And another one was massive email sending, and then IoT alerts coming in from devices in the field. So we had some customers sending in device events, and those events would trigger some kind of processing. That processing would aggregate the data and basically show like results and stuff. So
Great. I'd love to get a question.
Yes, yes. Hey there. I'm curious if you found some type of silver bullet to help, non-engineering developers embrace FaaS. Kind of a point in case here. So if you're running kind of a monolithic architecture right now, and you have your developers writing monolithic code bases who haven't quite graduated maybe to microservices even, but are kind of taking baby steps there, is there like a silver bullet that's helped folks adopt FaaS and really see the benefit? Because from an engineering standpoint, it makes a lot of sense, but to developers who don't necessarily have hands-on with the infrastructure, it might not make that much sense. And I'm just wondering if your experience, there's any particular selling point or something that might have encouraged that.
I think the question you made is important, because you're talking about development teams that are already or are still running monolithic applications. Obviously, there has to be like a journey. One of the things that I wouldn't do, especially on the journey to microservices or even function as a service, is to force on them, because that can be really dangerous. One of the things that I would do is to, if there is a service that is clearly can be decoupled from the monolithic application, it's like it has just one function, it doesn't have that many dependencies, I would start with that service, and I would add the infrastructure that is needed around before doing anything else, like especially monitoring, a lot of monitoring. You don't have to start with tracing with just one service or with just one function, but I would do a lot of the helping the teams understand how they can monitor those services and get alerts if needed. And then once they feel confident that they can do a lot faster development on that particular service, I will continue with the rest. So I think it's a lot about development teams gaining confident that this way will get them better results, but they still feel confident that it's not going to blow up, and they don't know how to debug it. I think debugging is one of the main difference between running a monolithic application and a distributed application. So I think they need to feel confident that they're going to know what's going on if something breaks.
So, Chad mentioned a minute ago about the DevOps use cases, and one of the reasons we've seen that as an early adoption for function as a service is because there's a lot of inconvenience there. there's a lot of repetitiveness and a lot of inconvenience. So, you know, you heard both Chris and Chad talking about these use cases where somebody has to do something manually, you're doing it repetitively. That's a great place to get started because it goes immediately to somebody's pain. And, you know, let's face it, you know, we all want to alleviate our pain and do something more productive. So that's why a lot of these sort of DevOps or cron type functions are really where we're seeing initial uptake in the market. From there, people tend to start to realize that whenever I have something that's a little bursty or I have something that happens infrequently, that's, you know, more or less an event rather than a continuous stream of data, it can be also a good gateway. Another use case we're seeing are gateways for APIs for microservices, but you're not there yet. And by the way, there's no silver bullet. There never is a silver bullet.
Great. I'd love to get some more questions in. Any?
I know in the past I've been in the industry since the mid '80s, and it seems like, you know, even then we were spending a lot of time on memory management. Do you see that coming up the stack so that memory management is not still spending a lot of cycles trying to decide how big your container needs to be or how big your base needs to be in order to run so many containers? Do you see that coming up to being automated in that stack?
Chad?
I'm laughing because I got grilled on this question the other day when I presented to a group of Java champions, and one of them, his entire existence, his whole consulting company was around memory management and dealing with memory constraints on Java applications. And so, I mean, my answer then is the same. The answer is yes. I think that we hopefully start to automate and profile our applications, and the system can react. I mean, maybe I can throw out like a crazy term like AI or machine learning or something to be able to do that. Yes, it has been a challenge from the beginning, and yes, it's still a challenge today, because when you run a function on one of the providers or even on one of the open source projects, you have to specify how much memory you want each function to be, and you'll get an out of memory error if you run out of memory. And so you still have to think about that. You still have to profile. There's a whole lot of kind of thinking and complexity to that, and we're not there yet, but I think it's an area that we need to get to.
But when you have memory constraints due to concurrency, this is an area where I think you might find function as a service being really helpful, because again, if you're running a lot of processes, that starts to suck up lots of memory, especially in a Java stack. God. Yeah. And if you're instead partitioning those concurrent processes out to lots of functions because it's expanding, you know, the number of functions running can expand as it has to, then that'll alleviate some of your memory management problems.
Sorry.
I was going to say, one of the things, when you begin architecting in terms of functions, it actually makes you think about fault tolerance. And what you end up doing is actually building functions where if they fail, another one is run. And so one of the things you can actually do is go, this function failed because it was an out-of-memory error. I've got the exception for that because that was returned to me. I'll now fire it off again with a higher memory limit. And you build these things into the application. So it's things we've been doing on big supercomputers for couple of decades now, where essentially you build fault-tolerant applications. What functions as a service does is really let you bring that into the application space and not just have the standard signature for this is the argument, but actually the standard signature for this is the error, so you can then deal with it. So it's almost like exceptions, but we don't quite have it as exceptions yet, but I'd love to see that.
In terms of memory, I think that brings also maybe a wrong use case, or maybe not a great use case for function as a service, is when you have to do some calculation on some, you have to load into memory a lot of data before doing the calculation, because basically you spin up your function, then you spend a lot of time loading into memory, then you do a quick load calculation, and then you turn it down. So if you have to load a lot of data into memory, to just then a super quick calculation might not be the best use case for functions as a service. You want to run that for a longer time so you don't lose that data.
Questions?
I'm not very familiar myself with function as a service and serverless. So a super basic question I have is, what sort of interface is there to sort of call the function as a service, if you will?
So in a common interface is basically it's just an HTTP endpoint. So what you're doing is effectively creating code that's sitting behind a URL, and you call the URL. So basically you can post, and you'll post in then the arguments, and then the return from the call will be the result. But that's kind of the basic level. We're beginning to move more towards actually there are other ways you can call the functions. But if you think of it, it's just like it's a URL that does something more than send you a web page. That's kind of how I view it.
Yeah, so HTTP is one trigger type. Others that a lot of the services are adding are things like AMQP, Kafka, triggers from other cloud events coming across the cloud provider. So it was originally coined event-driven or event-oriented architecture or event-driven. I mean, this stuff is it's all a big cycle. Technology cycles come and go. But that's how it was first marketed because it's very event-driven in terms of its pattern. And yeah, HTTP, Kafka, all those types of things are great trigger sources.
Question?
Thank you guys for your time, and lady. So quick question coming back to Chris on the first comment you made about long-running processes. Was that the most cost-viable way to run functions in a serverless model?
Ultimately, I would say yes, because you're using, so for example, one of the long-running processes would be I need to have 20 nodes to run this big HPC simulation, and I only want to pay for when those 20 nodes are up and running. So if I was trying to basically provision a Kubernetes cluster which had the 20 nodes as part of the Kubernetes cluster, it would be really difficult to have those 20 nodes spin up and down as part of the Kubernetes infrastructure. But running it as a serverless function, effectively the 20 nodes are provisioned at the point of the function call, thing then runs on the 20 nodes, and at the end of it, those 20 nodes are turned off. So I'm only billed for those while those 20 nodes are on. I don't think there's any other way that I could have got that cheaper.
I work for Microsoft, and we often compare Azure Container Instance to Kubernetes cost, and typically the ACI long running is more expensive than running on a node if you optimize correctly. So I'm just wondering if you actually honed in on the cost analysis before making that decision.
Yeah, I mean, for the platform I'm using, the cost, the way it's built is basically billed per core hour of the node. It doesn't matter how what particular service is running, so there's not a cost differentiation between using serverless and spinning up a VM and running that.
I think you also want to calculate the time in engineering. I mean, people definitely undervalue their time and the amount of cruft they have to write in order to manage those nodes. So there's some overhead to having to think about, do I need more of these? Do I have to write some code? What if that code fails? Someone has to debug that. So there is some overhead to that.
So there are ways that you can start to calculate this based on how bursty it is. And so, for example, I may have a group of functions that are running for quite a long period of time. So that might seem in the short term to be more expensive. But then it's not like I have to commit to it for the next 6 months or the next year or even the next month. So sometimes when you need capacity in the moment, even if that moment is kind of long, that might be an important way to look at it. When we started doing the research on it, one of the big use cases really revolved around infrequent or bursty events. So if I'm sitting here at an IoT gateway, but I'm only getting telemetry occasionally, that's a great use case for it, because if I have to spin up a VM that's going to be there all year round just to wake up once every 6 months, it's really a waste.
So why do you need Kubernetes?
So I mean,
I'm curious. I mean, as a question. I mean, because I'm curious. All we're talking about here is FaaS, 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 FaaS. We haven't even talked about Kubernetes. So here we are at KubeCon.
I can talk about that. One thing I would say is, I forgot to say about the cost question, is it's moved us away from basically costing for the peak load, and now we cost for the average. So ultimately, we don't need to size things for what we think will be the peak usage, which I think is one of the issues we've had with Kubernetes. It doesn't, in terms of actually pod scaling, it's not as fast as it could be. In terms of why we would need Kubernetes as opposed to just FaaS, well, actually, you then have more than just FaaS. You have to have something running that's going to pull all of these functions together. So what we use is basically Jupyter Notebooks, and it's Jupyter Notebooks are calling the functions, and Kubernetes is basically enabling us to have auto-scaling Jupyter Notebooks, and it's a really powerful thing for that. And in terms of why Kubernetes, I see that, do you all remember the LAMP stack going back into the 90s, 2000s, which is how you wrote web-based applications? We're now writing cloud-native applications, and I view there is now a cloud stack. And the cloud stack is essentially object stores, containers, container orchestrators, function services, and then notebooks or workflow managers. And ultimately, Kubernetes is established now as being the standard container orchestrator. I think Docker's pretty much now the standard container. What I'm really interested in is what's going to become the sort of community standard function service, because at that moment, I think the whole FaaS area will just explode, because we then won't all be tied and afraid of, AWS Lambda or afraid of Azure Function. We would all suddenly be writing these wonderful cross-platform multi-cloud functions.
It'll be galactic.
Right, and there's actually a project under the CNCF called the Cloud Events Project, which is all about creating these standard events, so you'll have that cross-platform capability. Because right now, you're right, if you're running one thing on Lambda and you're running one thing on premises, you might have some serious difficulties.
Great. Well, before you mention, I'd love to get another question. Is there questions here?
So can you recount a time that while during one of the stages of transformation from mono to micro or from micro to FaaS, you realized, wow, that was a bad idea, I should have stayed where I was?
So I guess, so normally if that happens, is because you went through that journey too fast. So I think it depends on whether you're starting with a greenfield versus a brownfield. So if you already have a monolithic application, you're going to feel that you need to move to something else when you start having issues, especially when you have to deploy new features. If you want to deploy a small feature and it takes ages to do that, then it's a good sign that you need to start. But then it doesn't mean that you have to do everything in one chunk. I think it's very unlikely that if you do that step by step, again, I think monitoring is super important from an infrastructure point of view. If you do that step by step, it's very unlikely that you go to the end of the journey and say, oh, this was a bad idea. So I think it's more about, it's a challenge. It's a macro challenge. So it's not a project that you can finish in 3 months.
I think it was actually yesterday I did an interview, and I think it may have been Andrew who was here, about you don't eat an elephant in one bite, right? It takes time to eat this elephant, right? But one of the questions I keep thinking about is like the team building that you have to do, because you can't just do it all at once with like the team you have necessarily. You may have to find all kinds of different people who can fill these roles, because it's not just the compute and the application, it's the storage, it's the networking, it's the monitoring, it's all those different aspects, isn't it?
So yeah, so you do have to. So this is so I'm very lucky because I work at university. I just get students, and it's my job. My job basically is to.
Now we hear the real truth.
So basically, my job is basically to mentor the next generation, and I think it's actually important for all organisations to do this. You want your juniors to eventually know more than you and go further than you. I think that should be the goal of every manager, and. The way we get these people is they come in obviously not being cloud experts and not being storage experts, and then you upskill them and you mentor them. So one of the platforms I use a lot is Google App Engine. Who here has used Google App Engine? So it's been around for 10 years. I actually think it's the sort of the original serverless platform, because it's basically Python functions running object stores. You don't think about the underlying infrastructure. And I get the team to basically build things in their free time and just suggest kind of technologies to them for their 20% time to build stuff. And then you bring them onto projects and you mentor them and you show them, and effectively you build it all together. I think the world where you have the network person and the storage person and the cloud person and the architect person, that world is ending. And I think we all need to know a little bit of everything, but we don't need to be experts in all of it. And we should trust that actually Google's our friend. Looking at other people's work is really useful. Networking at events like this are really great. And you just have to accept you don't know everything, but you'll learn what you need to get the job done for today.
Yeah, serverless creates owners, I think. It forces people to own an application as opposed to say, oh, here's my little bit of work, I'm going to throw it over the wall. So I think from a team perspective, it creates a bunch of owners who care about something, and I think that's really an exciting shift.
And one of the things about mentorship, I think one of the best way to mentor people is to push the boundaries. So to give them jobs they haven't done before, obviously with help, with time to research, and that's how people learn. That's how people grow.
Joab, questions? Are there any questions out there? Joab's got the mic.
From a DevOps perspective, is there any challenges moving from a mono to a micro environment that are common stumbling blocks, and how would you overcome those?
Can I go for this one?
Sure, Tom.
So I had a period of time when I kind of left the analyst biz and went to work for a bank, and in a big digital transformation project. And one of the things that I saw there, and in my research I've continued to see, is the biggest stumbling block tends to be culture. And when we talk about don't eat the whole elephant, well, one of the problems with that is it gives opportunities for people to carve out a space that they don't want ever changed. And they keep it that way. And hence you'll have some part of your infrastructure that's getting older and worse, kind of like me, getting older and getting worse and falling apart at the seams, and yet there's this protective boundary around it. So really, though, it's not even just a matter of upskilling everybody. It's about really transforming their idea about how software is developed so that they understand a collaborative, team-oriented approach. And one of the biggest problems when you talk specifically about DevOps is there's always been this sort of, here's my developers, here's my operations team, the two shall never be the same. And there's reasons for that. And one of the reasons is it gives them power. So the hardest thing is going to be breaking down power structures to enable that team-oriented DevOps approach that really is essential to working a microservices architecture, to making that really happen.
Well, that summed it up. All right, question.
Not a question so much as an observation. So Ara and Tom, I work for a team right now that's doing the third round of this at another company. We keep getting pulled to move people from mono to micro. You're dead on. It's not so much a technology problem as a culture problem, so to Tom's point, and also we build in all the monitoring and the logging to make it convenient. But we also have to write a ton of deployment readiness examples and a ton of documentation, because people will treat containers the same way they treat virtual machines, as bare metal. So that's not a good practice. Right? You've got to decouple all these things. So we did exactly what you suggested, which is, and this gets back to the silver bullet question, where there isn't one, but I would think that we found a team who could easily decouple from our application, to start moving them and use them as the champions to evangelize, convince, and use those patterns over and over again. So not so much a question, but just a supporting. It's good feedback, because eventually we want to get to feature as a service, but we're so mono, that's going to take us 2-3 years.
So I recommend for that mental shift. So Brendan Burns from Microsoft, he wrote a book. It's super tiny. It's called Designing Distributed Systems. I think it's available for free, and it gives design patterns for exactly that, distributed applications, and reading it is very easy. So I really recommend it as a way for people to understand how you actually design these new applications.
That is a really good book. I just read it last week, but it's a really good book.
For what it's worth, I actually see that a lot with our customers. Is there's like a champion team that starts to spread. It's like starting a movement. One team has to champion it. They have to be the ones to learn the best practices, and then that starts to sort of work its way outwards to other teams.
Question.
So since we're on a culture trend here, and speaking to the growing technical skill set and that sort of thing, let's say you're hiring a greenfield team. What am I looking for? I like that one of you mentioned the LAMP stack. I got several jobs by putting LAMP on my resume. You can't do that right now. What are we looking for in potential candidates to hire up for a FaaS type team?
So on all of my job adverts for my team, number one thing is good communication skills. People who can actually talk to each other and communicate what they're doing and really explain where they're going. Then beyond that, inquisitiveness, eager to try new things, eager to learn new things, eager to document what they're doing. I think that's a really, again, these all come back to communication. It's how you work as a person. Ultimately, you assume, yes, there's a base coding ability, but actually if you've got someone who can talk, who can actually understand, communicate, understand, document, and they can code, I think you can then mold them into whatever you need to make them. Admittedly, people I tend to get are very young because we take them for university, so they are more moldable. In terms of people in their 40s, 50s, I don't know.
So I do want to say be careful about ageism here, because being older doesn't necessarily mean that you're closed off. And I've run into a lot of young people who found a comfort zone when they were 25, and now they're 26 and they're still in that comfort zone and ain't leaving. So one of the things I think that really helps is, besides the social and communication skills, which we've always wanted that in our hiring, no matter what, I do think it's that openness to experience. You know, if you get people who really are looking for comfort, then this is going to be a tough place for a little while.
Era, who do you have on your team?
Say again?
Who do you have on your team for building out your own platform and architecture?
So we have a team of software developers. We have people on the SRE team. But one of the great things that we managed to happen is that the people building the applications are the same people who then deploy them into production. So the SRE team, they provide the infrastructure, they maintain the infrastructure, but actually, and also they build some of the pipelines, but every single team are the ones who deploy to production and are maintaining production. And I think that's also, when I hear DevOps as a interchange name or as a new name for operations, that actually, I don't think that's the goal. Operations, still operations. You can call it operations, you can call it SRE team, you can call it the infrastructure team. This is the people who take care of the infrastructure. It's not about changing those people the title to DevOps. DevOps is more about culture again. It's about developers taking care of productions as well. And I think that's if you go to a microservice architecture or as a function as a service, you really need that your developers know how to run production, understand logging, monitoring, and take care of production. Basically, put them on call.
Yeah, and we always looked for, in my company, in current company, we look for developers who have a sense of ownership over the project. So not a developer who comes in and just wants to write technology for technology's sake, because that tends to kind of get stuck in the, like, I'm going to write code either the way I know it, or I'm going to write code because that's what makes me feel important. But I think what is important as a developer is that you're writing code because the business needs it. And there's a reason that they're shipping code for, there's a reason that they're getting paid to do what they do. And so we looked for owners, people who, you know, developers who have felt a sense of ownership and pride over the things they've built in the past, not because of necessarily the technical architecture of it, but because of what it created and what it did for the business. And that was really important. As we continue to move up the stack, I think that's the pattern we're seeing.
Question?
Yeah, regarding this idea of DevOps and have the people developing and going to production, I'm working in a bank, and usually the comment we have is that this is forbidden by law to have the same people to develop and to put in production. What can I do then?
Yeah, regulatory compliance, they're the bane of all IT, right? You know, part of it is to make compliance part of the team, actually. That was, the project I was in, that was one of the problems we had initially, is that they were never part of the team from the beginning. So there was a lot of lost time getting them, not just to show up for things like show and tells and stuff like that, but to get them to really understand how how we were going to deploy and how it was different than what they were used to, because in their world, different is bad, you know. But I feel your pain, and it depends where you are, how much, what the legal requirements are. I wouldn't say in the U.S. the legal requirements are really like that. That's just probably an overabundance of caution, which is really the way banks work.
So in that case, if it's by law it's forbidden to put the same team into production, it's not forbidden to put them into a similar environment. So what I would do is to use the same techniques of for your staging environment or your development environment, whatever you want to call it. The way they deploy to those environments is the same way it's going to be deployed into production. And the same monitoring, logging, tracing, all those tools are the same. So basically, they are the owners of deploying, for example, to staging, whatever that limit, low limit allows. So they're responsible of the actual moving into before production, at least.
Question.
Yes, I have a quick question. Just like I don't believe every application is suited to be a microservices application, not every microservice application should be automatically say, we're going to move this to a serverless. So what is the criteria which you use to say whether or not this should be a microservices application or I should move it to a serverless type model?
I would argue how atomic it is and how much you're going to be revving something. Typically a microservice, the reason you do microservices is so that you can create a piece of code that can be independently evolved, right? If not, you're just adding to your network traffic. When you want to talk about serverless, I think you're really talking about function as a service here. Again, it comes down to the characteristics of your application or of your code versus what you're doing now. I mean, that's really what
Also, I don't think it's an all or nothing. Your microservice architecture has endpoints. Each of those endpoints can be looked at independently. So if there's one that lends itself really nicely to a particular function, or maybe it could be better used by integrating one of the services from the cloud provider that takes away the functionality that you may be doing, you can carve out that endpoint and move it over to that service. So it's not all or nothing.
I was going to just have a question for right up front here. I'll hand the mic. Andrew?
It's actually not a question, sorry. But I want to go back to this comment that the gentleman made about compliance. And I've had the misfortune of working with a lot of big banks and like governments, and the letter of the law is often misinterpreted. So if someone's saying this is illegal, it's actually not true in many cases. And so force the issue with them and with the auditors to get to a point where you can look through and make guarantees about how this new way of doing things in an automated fashion actually has compensating controls that are going to give you more compliance, more auditable, more visible, more controllable compliance than you ever had before. And then you can move into this like new world that everyone wants to live in. And that's something that you have to do. It obviously goes back to culture, but a lot of times when people are digging in their heels and they're saying this is against the law, it's actually not true. And so I don't know the specifics of where you're at and what regulations are, but I would encourage you to go look at the letter of the law and like walk through that with the auditors.
And I would say on that, one of the best talks I saw on DevOps was, I think, from a company called Global Med that basically has integrated prosthetic manufacture with software development, but they actually put all the compliance for FDA as part of the DevOps cycle, and they brought in FDA officials to then look at that, and they co-developed it with them. So all the documentation is actually developed as part of their cycle, and so the compliance is done.
Stronger compliance, actually. Stronger guarantees around it.
You want to add anything to that? Anyone about the stronger compliance?
Well, I mean, if you think about an architecture that allows you to have such fine granularity, it also means you're going to have fine granularity in your logging, in your security, and all that. So, yeah, you can create a better application from a compliance perspective. But I totally agree. A lot of it is just, compliance and parts of organizations like that get used to doing things in a certain way that they know is compliant. And then when you tell them to do something different, They don't know it's not compliant, so they'll tell you it's illegal or it's not compliant, when the reality is they don't really know, and they, but you do, I agree, go force the issue and say, well, why don't you go research that for us and find out if we can do this in a compliant way.
Great. Well, the keynote's coming up pretty quick, and so we want to just kind of finish things up here. So, first of all, let's do a drawing. Let's start the draw. All right. Who's gonna?
Did everyone get their tickets? No. What?
Is that the prize?
All right.
In the meantime, I want to thank Oracle for sponsoring the breakfast. Thank you very much, Oracle. Let's give them another big hand. And I'd also like to thank our panelists, Era, Chad, Christopher, and Tom. Thank you very much for participating. This was a lot of fun. And to everyone here, the questions were awesome. Thank you so much for coming. We're having another breakfast tomorrow, so look for it on the schedule. So do we have all the tickets?
Everybody got a ticket?
Everyone got a ticket? All right.
Blue ticket number 574105.
Who said woo? All right. The first question of the day goes to the person who asked the first question of the day. Guess you're doing it. Okay, well, thank you very much, everyone. This has been a lot of fun. Have a great show.
Thank you, Alex.
This episode of the New Stack Analyst is brought to you by Oracle. Oracle Cloud Native Labs is here to empower the next generation of cloud practitioners with a curated set of solutions, tutorials, and best practices, all designed to spark inspiration, drive hands-on experiences, and unleash our industry's potential. Listen to more episodes of the New Stack Analyst at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.